Welcome to this presentation. Today I am speaking about the possibility to perform cryptography operation through OP-TEE with an Hyundai secure enclave. I am an embedded Linux engineer at Bootlin since 18 months now. We help clients to introduce Linux and open source software in their embedded devices. Before, I worked several years for an IoT operator and I am living close to Toulouse. This presentation is divided in two main parts. At first, I am introducing OP-TEE and PKCS 11 and also AMX8 SoC family. And in the second part, I explain how it is possible to build a Yocto distribution including required customization and software part to perform PKCS 11 operation in AMX8 through OP-TEE. So here the goal is to be able to perform OpenSSL operations with you use a secure element or a HSM or a TPM, so on. So for that, we will isolating secrets from the rest of the system and controlling their access. For that, the idea is to make them accessible only in secure mode and devices that will be used to store and to perform crypto operations will be only accessed from OP-TEE. So, PKCS 11 is a cryptography standard that defines a platform-independent API, defining callback to create, manage, and to store key and certificates. It's allowed to use the same software stack on several kinds of secure modules, as hardware secure modules, trusted platform modules, so on. This API can be used with some open source software libraries and tools as OpenSSL and, for example, OpenSSH also. OP-TEE is a trusted application environment. It is a companion OS which is isolated from Linux and can be used to perform some operations, how to access to critical devices. It is very useful to add an additional protection layers against Linux security vulnerabilities, especially 0 days. OP-TEE and Linux communicate through the secure monitor, which make the link between the normal world and the secure world. Here, the secure monitor is provided by the trusted firmware. OP-TEE can execute applications named trusted applications that can be either included in the OP-TEE OS binary or which can be provided from the user space. And trusted application can be also signed. So, the AMX8 SoC family provides a few interesting features that can be used through OP-TEE. In your case, to isolate key or to perform crypto operations. The hardware isolation on the SoC family is based on the ARM trusted zone and the secure boot on the NXP high assurance booting that allow to sign and to encrypt bootloader stages, including OP-TEE. It provides a crypto accelerator and a non-volatile storage, which are protected by hardware tampering features and that can be also managed by OP-TEE instead Linux. To be able to use OPTI on IMX8 SOC family, it is necessary to use a SPL stage because the ROM code is not able to load a boot container that contains additional binary as OPTI. The boot sequence or the bootloader image format may be different depending the platform. Some platforms use FIP image, which is a generic way proposed by the trusted firmware. It is not the case for IMX8. So, here the SPL will start TFA, then TFA will start OPTI, and finally U-boot. Here, boot stages can be also signed and encrypted with NXP code signing tools. So, we'll start the second part of this presentation about the implementation. To be able to perform PKCS 11 operation with OpenSSL through OPTI, it will be necessary to install a set of additional library and tools. First, we will install OpenSC that provides a library and OpenSSL engines that allow to access PKCS 11 module from OpenSSL. In addition, we will install the lib TKT that provides a T-client API that allows to serialize and to deserialize arguments sent to the trusted applications. In addition, it is necessary to install an OPTI client in normal world from the user space to be able to communicate with OPTI. We also need to install trusted application, especially the one that allows to perform PKCS 11 operation from user space. Finally, because OpenSSL does not provide interface to initialize and to import PKCS 11 token, it is also necessary to install PKCS 11 tools. Some Yocto BSP layers provide an OPTI machine features to enable or disable OPTI support on the selected target. So in this case, it is only necessary to enable the OPTI distro features. Then the BSP build parameters will be updated. Then SPL OPTI will be built and TFA will be rebuilt with the additional build parameters to link it with OPTI. Finally, to be able to perform PKCS 11 operation, packages have been identified, need to be installed in the rootfs image. Here, OPTI functional tests are also installed to be able to perform some additional verification before to create a key with OpenSSL. Concerning IMX8 target, it is possible that the mainline BSP does not provide OPTI support. So, in this case, it is necessary to use the BSP vendor by setting the variable IMX default BSP from Yocto. Moreover, maybe the OPTI PKCS 11 support is not enabled by default. So, in this case, it is possible to overwrite OPTI compilation flag with an additional parameters to enable it. It is also possible to increase OPTI lock level to debug it, or also to open a key that will be used to sign trusted applications. So, before to execute trusted application from user space, OPTI will check her integrity. And if you use a custom board, maybe you will also need to modify some default platform configuration like the UART. Here it is a few examples of commands that can be used to check that the OPTI is well probed and usable from the Linux user space. For example, here we can see that the OPTI driver is well probed and the interface have been well mounted. Here we are also execute OPTI functional test to validate it. Here, with this command, we check that OPTI is reachable through the CryptoKey API, and then it is usable to perform PKCS 11 operations. Now, it is an example of few commands to create a token that will be stored into the non-volatile storage provided by the IMX8. And here we check that the token has been well created and with correct flags. Finally, here we create a key with OpenSSL over PKCS 11 and OPTI. Do you have a question?